So thank you everybody for attending and hello, welcome to Golang Live, part of the live series events over at Amicus Recruitment. My name is Jake O'Regan. I am the Golang Specialist Recruitment Consultant for Germany and for fully remote vacancies over at Amicus Recruitment. And I'm delighted to be joined once again by Robert. Robert, who is the head of cloud over at Once in Germany and is a Golang expert himself. I'm sure he won't mind me saying that about him. But yeah, the webinar this evening is titled Infrastructure as a Code using Go and CDK. The way that we are going to run this this evening, if you do have any questions, please use the Q&A box down below. We'll try and keep it as interactive as possible. I'll interrupt Robert where I can, and yeah, we can answer questions as we go along, and also give a few minutes at the end for people if they do have any questions to put to Robert. That'll be fine. So the webinar should last around 30 minutes or so. And it will be fully recorded. So if you do miss anything or there was something that you'd like to go back to, then it'll be fully recorded. And yeah, you can watch at any point. I'll make sure everybody receives a link tomorrow morning for the YouTube link. Okay, so without further ado, Robert, over to you.
Thank you very much, Jake. All right. So my name is Robert Tingirică. And yeah, Jake already said that I'm working as the head of the Cloud Center of Excellence here at Once. Once is an IoT connectivity provider with a disruptive pricing model, and we have quite a few workloads in the cloud, as you might imagine. So in the past, I've been working as a developer, as a cloud DevOps engineer, and that's how I gathered this experience. I've been an OpenStack contributor for quite a while back, and now I am doing this, and I'm really happy to have you guys here and go through this journey of using Golang for infrastructure as code, specifically using CDK. As Jake already mentioned, please feel free to ask your questions. I'll be more than delighted to stop and answer them. I like to keep this thing interactive. Not the best situation in Corona times when I'm not in front of an audience, but let's make do and make it as good as possible. All right, so what is infrastructure as code? So maybe you've heard about some tools that are used to define workloads in the cloud before. Some things that come to mind are Terraform, CloudFormation, even for serverless workloads, something like Amazon SAM. But Pulumi, as you can see here on screen, is something that's closer to CDK, whereas with the other tools, you're defining basically your workloads as machine-readable definition files. Through these interactive configuration tools, you can deploy those statements into the cloud. With things like CDK or Pulumi, you can use an actual programming language that you might be familiar with to do the same thing. So instead of doing it in a declarative way, you would be doing it in a more imperative way. So basically, you would get from something like this on the left-hand side to an actual object in the cloud on the right-hand side. So in this case, we have a piece of code that is a CloudFormation template. It is YAML, and from that YAML, this S3 bucket would be generated inside of your Amazon account, given that you deploy that piece of code. So the definition needs to be executable and idempotent. These are a few properties of infrastructure as code in general. The nature of infrastructure as code, as I mentioned, is declarative. Thus, the languages are more leaning towards configuration rather than code in these examples. But we'll have a look at sort of a different paradigm with the CDK. Right. So CDK, what is CDK? Well, the Amazon Cloud Development Kit is a way to define infrastructure as code using a programming language, and not one of these configuration languages. So you have access basically to the definition of these resources using libraries, but you also have access to terms that you have in your normal programming language. So you can write for loops, you can write if statements, so on and so forth. And given that your programming language is also a static type programming language, things like IntelliSense and testing become way more easy to do compared to something like pure Terraform or just YAML files. Okay, so in terms of CDK, we have these other programming languages that are not Golang that are fully supported. So we have Java, we have TypeScript, .NET, and Python. TypeScript, I think, has the largest community. Don't quote me on that. I think the features that you also get in CDK are first coming out to TypeScript and then to the other programming languages. Python is probably another very commonly used programming language when it comes with CDK. But from my experience, and this is very subjective, like tried out Java CDK, I didn't have quite the good experience that I had with something like TypeScript. All right, so what about Golang? Well, now Golang is also one of these languages that is supported. I say supported, but I don't actually mean production ready. I think it's still currently in preview. So take that with a grain of salt. We'll be going into some of these features today, but the APIs might change just because it is a preview. So basically the maintainers are free to do whatever they want. And if they want to make breaking changes, they will do so. So this presentation might get outdated. But yeah, let's, if you want to read more about it, there's the link over there for the announcement. But yeah, let's dive into it. So how do you actually get started with CDK? Well, it's not very hard. All we need is basically to create a new directory and then cd into that directory. And then we need to execute the CLI command to actually bootstrap our CDK application. So as you can see over here in the recording of the terminal, that is exactly what I did. So created the directory, cd into it, and then just using CDK init, and then specifying the programming language I want to target, a new full application has been created. And yeah, it is literally that simple. Now, how do you install CDK? Well, that is a little bit of an interesting situation, because in order to install CDK, you have to do an npm command. We use the npm, so the package manager for Node, to install CDK. So that makes it sort of a Node, a JavaScript package. So you do have that dependency, even though we're writing our code into Golang. Okay, so what do we get after we do that init command? Basically, we get this file structure, a README file where we can put the documentation. We have the main stack definition for our application. We have a set of unit tests. Yeah, I know, unit tests for infrastructure. Yes, unit tests for infrastructure. It's quite exciting stuff. If you used something like Terraform before, maybe you tried writing tests with something like TerraTest, but if you write tests at all for your infrastructure, a lot of people just don't. These are quite different as they check just the code. So these types of unit tests that we have over here. With something like TerraTest, you do tend to call the actual APIs that are creating your resources. So it's a little bit of a different paradigm. Here you can catch a lot of these errors quicker, so you can write actual cleaner infrastructure code. Okay, and then we have the configuration file for CDK, that's cdk.json. We're not going to touch that. We're just going to leave it as it is for now. And then we have a Go mod file. So that means that this whole package is a Go module, and that's where our dependencies basically will be added. All right. So moving on, if we just open the definition of our code, it looks something like this, where we have basically just a type for our properties that will be passed into our stack, a function, and then the main function itself. So we should go step by step and have a look at this. So these properties get passed into our stack, and we are able to change them according to our needs. Because this is a programming language, Golang, we can define a module that we can also import and export using a package manager. And then we can also take advantage of this in creating modules that are logical units of our infrastructure. So you can do that with something like Terraform as well. However, here we can take advantage of the paradigms of the programming language itself already, using things like dependency, dependencies and the management of those dependencies and versioning and Go mod init and Go mod tidy and all of that cool stuff that you have already available. And other than that, we can also take advantage of testing these modules in isolation, because we can structure them in such a way that they can contain that logical unit of those specific resources that we just need for our application. And moving on, this is the stack definition itself. So here we just define a normal function that returns a CDK stack. And that is basically the core of it. Inside of the function itself, we can have a look at one of these resources that is being created. So in our stack, we just define one resource in this example, and this resource is actually an SNS topic. It's nothing special about it, but the parameters from this construct, if you have a look at it, basically take the same parameters that a CloudFormation template might take. So this means that actually this is a one-to-one mapping to CloudFormation at the first glance. But with CDK, since we can use the programming language feature to actually make the experience of the user of this library a bit better, we can abstract a little bit from that. So what we end up with is higher level abstracts that make our experience a bit better. Like we don't have to specify all of the parameters maybe that are required for a normal resource declared into CloudFormation. We can basically simplify the life of a developer that might use one of these libraries. So in this case over here for this SNS topic, the first parameter that it takes in is the stack that we have defined above at line 19. So that we know under which stack we are actually creating this resource. That is called the scope in this case. The second parameter is a string. However, there's this JSII thing that looks a little bit strange. We'll get into that in a second. And then the parameters that I just mentioned, which are basically the CloudFormation parameters in this example. Yeah, so if you know a little bit of CloudFormation and a little bit of Golang, you should be fairly at home with this approach. And then finally, we have the main function. Under the main function, we instantiate our application, which is that AWS CDK new application, doesn't take any parameters as context. And then we create our stack with the environment definition. The environment definition being the place where we define things like our context, for things like our region where we want to deploy, and other things like that. And we can see that the parameters that we have passed over there basically are the properties that we have defined above. So we have options there into actually giving more information about the deployment environment, and we can customize it to our needs. And finally, there's this app synth that's happening at the end, and that's basically an CDK API call. And app synth basically means translate this piece of code that I have written into CloudFormation. So there is an equivalent for this in the CLI. So you do CDK synth, and then that's exactly what happens. Your code gets transformed to CloudFormation because CDK basically gets transformed to CloudFormation. So it's this mapping between your code into what Amazon understands, so Amazon can deploy those resources into the cloud. All right, now, what about that JSII thing? Basically, JSII allows code in any language to naturally interact with JavaScript classes. So it is the technology that enables AWS Cloud Development Kit. Basically, without it, CDK wouldn't be able to deliver these polyglot libraries from a single code base. As I was saying, they are using they are releasing the features first for JavaScript, and then they can, using this technology, make those features available into other programming languages like Golang. So basically, Amazon requires us to use the specific type for strings in this case. So we are required to do this magic in order to translate a normal string into that JSII string. But if you just hover over that string method or the requirements, like the function signature of that new topic, for example, you would find that that's just a pointer to a string. So in this case, that's exactly what that function is doing. If you have used the Amazon SDK before, you might be familiar with this AWS.string function, which is exactly that. It's like a helper function that will translate your strings into pointer to string. All right. If you want more details, there is the project, the JSII project, and the link to the GitHub page over there. You can go through the code, you can go to the README, and you can better understand how this technology actually works if you're interested into seeing what happens behind the scenes with the CDK for Golang. All right. So moving on. How about those unit tests? I think they are pretty straightforward. So basically, we get an instance of our application over there, and the CDK app can have multiple stacks. So that's why we have these different layers. So you have your CDK app in which you can define multiple stacks. It just so happens that in this case, we define just one stack. You can have more CloudFormation stacks, literally. So these stacks translate to CloudFormation stacks, and you can define multiple of them for one single application. So we get an instance of that stack with the parameters that we want. In this case, just some mock parameters, nothing special. We haven't told our stack to do anything too complicated. It's just creating an SNS topic. And then when we have created it, we marshal the result from the synth. So that is our CloudFormation template that results from doing the synth command, and we do assertions on it. So basically, in this case, we are just getting that resource based on its display name, and we are verifying it that it is exactly what we expect it to be. So these types of tests can be run simply with Go tests, just like any other types of unit tests. So if I were to do CDK synth and then export that into a YAML file, I would be able to go down on the resources under the topic that I have created and its properties, and then check out its display name. Right. So moving on. So right now, if we have a look here, there's a button, sorry about that. Basically, we start off by importing the library, which is suggested by IntelliSense. So you can see how easy it is to use a static programming language to define a resource over here. So if you just look at the things that I'm doing, is most of the time just control space. And a lot of these things are auto-suggested. So is a static programming language right for infrastructure as code? I think so. A lot of these errors that you might have with a YAML file, you will catch quicker using a static programming language. So you can see over here that the new topic function that we are calling is auto-completed. Some of the same as the local variables, like the scope one that we have presented. Then the JSII thing got imported automatically. We had a choice for what exact library we needed to, and I didn't have to type any of that in. I just used the autocomplete. I know that CloudFormation can work with plugins from Visual Studio Code, and you can have autocomplete for it, but they're not as good as something like IntelliSense with a programming language where you can define your own primitives, where you can define your own types or your own structures, and then take advantage of all of this stuff. So your experience as a developer can be way better. And a lot of these errors can also be caught very, very quickly during development time, straight in the IDE. So you don't have to like execute any commands to actually see that, you know, you have a failure or anything like that. So you might have noticed earlier that I also added the wrong type in there, and that's why it was highlighted here in red. And you know, stuff like this I can also catch with the with the editor that I'm using. So then it becomes a simple matter of just checking the function signature and then adding the correct type to the parameter that I wanted to pass in. So moving on, is static programming language right for IAC? I think it is. I think infrastructure as code can be represented with something like Golang, just to answer the first question. But again, this is just my opinion. If you prefer writing YAML and you're very good at it and never make typos, go at it. But I think I'm human, I make mistakes, and I want to avoid making those mistakes and be as productive as possible. So I'll just stick to something like Golang over here. All right, so is this actually production ready? Well, to put it simply, no, it is not. This screenshot over here on the right-hand side is actually coming from the documentation page that we have available for, in this case, the Amazon Lambda module. And as you can see, only the 4 programming languages that I mentioned in the beginning are presented over there. So I wouldn't recommend you rewriting your whole infrastructure for your company right now using Golang yet. But as soon as that becomes generally available, I think it could be a good candidate to do that. So if you go to the docs page for any module, not just this one, you'll see the available programming languages and their associated libraries that you can either install using the package manager for that programming language, or just download from GitHub or wherever they are referenced. So it has still to grow a little bit. There are some caveats around it, and we'll get into that into a second. But basically, try it out, but don't make your business depend on it just yet. All right, so building actual services with Go CDK. So over here, this is the documentation page for Amazon Lambda Go. So let's talk a little bit about that. This module allows you to deploy a Lambda function, and that is just like the Amazon Lambda function module that we saw earlier. However, the code for that Lambda function, given that the handler is written in Go, you would be able to compile using this automatically. So normally you would have to compile the binaries, upload them, package them, and then upload them to something like S3, and then reference it from there, and then take advantage of rotation of those binaries and versioning and whatever. But this is the advantage of having an actual programming language be the way in which you represent your infrastructure. You can abstract from this, and you can just do the CDK command and have this module do all of the magic for you. And I recommend going and having a look at this particular module, and you'll see an explanation over there on how you can actually structure the code for your Lambda functions so that they can be deployed using this module. You see that we also reference over there the other programming languages. That's because the library itself is meant for defining Lambda functions that have Golang as the main programming language for the handler inside those Lambda functions, but the infrastructure itself can be represented into something else. In the past, I've also written a module in TypeScript in CDK, but the code for the handler itself has been in Golang, just because of performance reasons, or because it's Golang. It has to be better, right? So this is where basically the documentation also comes in, and it's really, really handy because it tells you how to structure the code, which makes it a little bit opinionated, but it really makes it really quick to iterate over building some small services. So if you just have a look in there, you'll see like, oh, okay, if I just put my code under this file structure, and then I point this definition of the function to that particular directory, everything gets compiled for me and it gets deployed, which is exactly what I want as a developer. I just want to deliver the features as fast as possible to my customers. I don't want to have to faff about with all of the configuration details or anything like that, because it's just not necessary. All right, so I'll try to deploy a basic API app using this, but I hit a few problems when I actually tried to do this. So as I was saying, I actually created that directory, and I'll show you the structure in just 1 second. But then basically, if you put your module for the Lambda functions inside of this bigger module for the CDK application, you will hit an error such as this one from Visual Studio Code, because Go PLS basically cannot understand things like loading from your dependencies and stuff like that. So you have a few options to fix this. You can go one directory up and do code period in there and actually open another editor over there where the root of the workspace is actually the Lambda application itself, or you can basically structure them in parallel. So you will have a directory where you're defining your CDK code and then you're referencing it relatively a few layers down when you're pointing to where the code for the Lambda function actually sits. So just to clarify how that app structure looked like for me, basically this basic API app is the new addition over here. So basically here's where I have my handler function, and inside my app serverless CDK Go, I point to this directory over here where I have my main.go, and you can see the Go module definitions over here. And this basically gets compiled and gets uploaded wherever it gets uploaded, wherever CDK keeps its binaries. I don't have to care about that. And then my Lambda function just gets deployed. And yeah. So notice this Go module. Basically, these dependencies over here are dependencies just for the Lambda function, whereas the Go module from over here hosts the dependencies for CDK itself in this case, just to make that point really clear. All right, so how does the Lambda function definition actually look like? Well, it looks something like this. Basically, from the library that we have commented out over there, we are importing AWS Lambda Go, and we are calling new Go function. We give it the scope, which is the stack, just like we did with the SNS example earlier. Then we give it the logical ID from CloudFormation. So basically this string right here, which will be identifiable in the CloudFormation stack. And then the properties that we actually need to pass into this Lambda function. So just like a normal CloudFormation definition, the runtime, the entry, and in this entry parameter, this is where the differences actually start to happen. Because we're pointing to a directory, which is where the code is at. We are not pointing to a binary itself or anything like that, or an index.ts file, or the main py file. We're pointing to the directory that will be compiled, and those binaries that will be compiled are the actual handlers themselves. And then if you have any special needs for your Lambda application, you can pass in the extra bundling options. So things like the Go build flags are also available to you. In case you don't have Golang installed locally, that's perfectly fine. This library itself will actually pull in a Docker image, and we'll try to compile it on there, so that if you don't have Go in path on your local environment, it will just do it isolated in a container, which is yeah, a really cool way to actually keep your running computer environment where you're doing your work clean. Maybe you want to execute it in a different version. Maybe you want to work on other versions of your applications locally, stuff like that. So you have options. All right. So in order to actually deploy the application, the first thing that we need to do is CDK Bootstrap. And this basically creates the resources inside of the cloud, things like the S3 bucket, where our synthed, like compiled, let's call it compiled, CloudFormation template will sit, where it will be uploaded. The binaries after they have been compiled, given that we're deploying one of these Lambda functions. And yeah, and after that, you can, after we execute that command, you can actually see that these resources get created. So this in itself is also a CloudFormation stack. So there's nothing special about it. CDK deploy, after we will execute it afterwards, will just know to point to these places and upload the stuff that it needs to upload over there. So you can see these CloudFormation events, as you saw earlier. And you can also see over here that we have deployed our Lambda function, but we also have automatically created the role that's actually needed by the Lambda function, and the assume role policy is also added to it so that this Lambda service itself can assume that role and can take the actions that the Lambda function takes. For example, write to CloudWatch would be a good example of that. So the resources over there, the managed policies, all of that stuff, all of these events are also present, and we can also view them in the web browser. If we open up the CloudFormation definition over there, the CloudFormation service, and then we go to the CloudFormation deployment. And yeah, it takes a while until the functions get compiled, but basically you can see over here, this publishing, the start and success of the publishing is actually that special magic that happened from that AWS Lambda Go library, where the compilation happened before the actual creation of the chain set in CloudFormation. All right, so right now the creation is in progress. The last resource has been created over here, and everything has been successfully deployed. So yay, we got from nothing to something running in the cloud. All right. Now, sorry, it's time for a little bit of a demo because nothing goes wrong when you do live demos, right? As we all know. So let me switch tabs over here and go back to the code editor. So besides the Lambda function that we previously had open over there, you can see the file structure over here. You can see that this thing also appears in red, as I mentioned, because this is where I'm keeping that other module inside my module. So nested modules don't really work that well yet. But if I just zoom in here a little bit, you can see the lines here with green. And basically what I did was I added the REST API so that we can add an Amazon API gateway resource in there and actually point to our handler and call it via the API, via a curl command, an HTTP request. And on that REST API under the root resource, so that would mean / I am adding a resource that is called health. So basically, if I call this API /health, I would be calling the Lambda function integration that I do over here. I'm saying that I want this to be a GET request over there, and the GET handler over here is the Lambda function that I previously deployed. So then I'm not passing in any configuration. This is one aspect that I don't particularly like. Whenever you don't have extra configuration to pass in, you still need to pass in an empty object such as this one. So that can be a little bit verbose. However, if you do need it afterwards, like it can be really convenient, because all you have to do is do just control space, have autocomplete tell you all of the stuff that you need to actually configure. And then for integration responses, if I want more details, I can just control click on it. So I can do all of that here just in my editor. I don't have to open up the documentation page for CloudFormation to figure out what this resource does and what this particular parameter that I'm passing in actually does. And then, the default method options, which is again a required parameter. So I have my Lambda function, I have created a new REST API, and I have added an endpoint on that REST API. So now I can just come over here and then do CDK deploy. And fingers crossed, this is going to work flawlessly. Famous last words. All right. The good part about CDK is that I get the diff over here of the resources that will be created or removed if I'm deleting something over there. However, I can have access to this. So let's Control C out of this one and actually do CDK diff. So we can actually see what gets changed. If you have like a CI/CD pipeline, maybe before you actually approve your changes, you can do this and see all of your actual resources that will be added and then see if you want to approve it or deny it and get it to the next step. So if you're familiar with something like Terraform plan, this is very similar, except when I do CDK deploy, I don't have to specify that plan. I just point to the code. All right. And then also my outputs are defined over here. Basically all the information that I require for my particular deployment. All right, CDK deploy, going back to it. You can also skip the approval step over here, where I don't have to do yes every time I want to do the deployment. The start publishing has been initiated. So the code that I have over there for my Lambda function gets compiled. And then I see that it has been successfully published. With Golang, the binaries are pretty small, so you can keep the Lambda function layers quite low if you are careful with your dependencies, which is quite a cool thing compared to other programming languages. That's one of the reasons I like to use it when writing Lambda functions. And then our CloudFormation changes are being created. So if I just put this to the side and open the browser over here and go to CloudFormation, I go to events, and then basically if I refresh, stack info first, and if I refresh over here, I see that the update is in progress. And then for all of the things that I see in the terminal, I can also see in here. So I see that this handler service role has been created. This is the new version of my handler because the code has been changed and has been compiled again. And it got updated for the handler itself, and a bunch of other resources that are also being created. If I want to see the resources, I can also go here. So I have access to all of the things that I have normally with CloudFormation. And I see some got updated, some got created, and there's still one that's in progress over here. That's completed. Back to stack info, update has been completed. So if I return to my terminal right now, I should have an endpoint as an output. So using this endpoint, curl, let's say that we want to do a get, and let's paste in this new endpoint. And remember, we added our Lambda handler under health. So we need to pass in here health. And then, yes, we got some information. So let's make this a little bit more readable. JQ, there we go. And basically the event itself, I also captured in here, and I returned, which isn't something that you would generally do on this type of API. But yeah, just for debugging purposes, I wanted to do it to emphasize what exactly we have access to over there. It has been successfully triggered, and also if you want to do a couple of calls, this is the endpoint. I'll be tearing down the stack after this presentation. So yeah. I don't know if I can paste it anywhere in the conversation. There's a chat. Oh, there we go. Perfect. If you don't have JQ, there we go. All right. So my Lambda function that has previously been deployed over here has logs enabled as well. So I can see, yeah, I can see its configuration. I can see all around it. I can see the previous executions that have happened. And then in CloudWatch, I can also see the latest log groups, and I can go to them and I can read more about them. I'm not printing anything in there, but I could do more debugging if necessary, and I could make this more relevant. So for this particular Lambda function, if I were to open it, I have the option, if I'm using particular clients like HTTP clients or anything like that, to also capture it using X-ray. And then I have distributed tracing also enabled for my service, so that I can see inefficiencies between my API calls, or I can spot problematic parts between my microservices if I have multiple of them communicating amongst themselves using something like the correlation ID. But in this example, I am not using that. So we can, I have just commented that out. but this is an option. And I can use the init function that's generally available inside of Golang to actually instantiate my clients and do it just once for when the function initializes. So I don't have to do it in my main function all the time or inside of my handler that I'm mentioning over here. Yeah, so that was successful, so yay. So going back to the presentation, that has been it. So if you'd like to reach out to me, that's my handler on GitHub, that's my page on LinkedIn, and the code to this project is over there under my GitHub page. If you would like to have another look at it, it doesn't include the definition of the REST API, because as you saw it, it appeared in green over there. But once I commit that and push it, you should have access to everything that we have deployed here today.
Amazing.
That is it.
No, thanks very much, Robert. Fantastic presentation as always. This is time for anybody who has a question to pop a question over. But just to remind everyone that it has been fully recorded. Obviously, Robert's put his details on there for anyone to reach out to with any questions. He believe me, is more than happy to answer those for you. But no, thanks again, Robert. I think obviously there was a lot of people that have just left as well, so we'll leave it there. And thanks again for your time, and thank you everybody for tuning in. That was a fantastic presentation. Thank you, Robert.
Thank you very much.
All right, take care. Thank you.
Bye-bye.
Cheers.